narrow by limiting the phenomena under study. So, you might not look at all droughts. You might look only at long-term droughts. Or you might look only at droughts that affect plants. Or you might look only at droughts I think of other ways to limit the phenomenon. Well, there's two kinds of droughts. There are temperature-driven droughts, and there are precipitation-driven droughts, right? You can have droughts that are caused because it's too hot, or droughts that are caused because there's not enough rain. So you can separate that out. I'm going to study only droughts that happen because of reduced precipitation, or only droughts that happen because there's too much temperature. So you can limit the phenomenon under study. If you're and I hate to use this example of viruses, but I'll use it because it's a good one. But you don't have to study every virus. You can study just viruses from this one family, or you can narrow it down to this one particular species, and that is helping to narrow. You can narrow by geographical area. You might study only the western U.S., or only sub-Saharan Africa, or only Australia. You can limit it by time period. Maybe I'm only going to study the Dust Bowl in North America. Okay. You follow what I'm saying here? This is how you go from a big idea to a narrow project. These are your three main limiters. The phenomena that you're studying, the geographical area in which you're studying it, and the time period in which you're studying it. Let's suppose that you're studying paleontology, you're studying dinosaurs, right? You may only study certain kinds of dinosaurs, theropods. Those are the ones like Tyrannosaurus rex. It's one type of dinosaur. You may only study theropods that lived in what is now North America, and you may only study theropods from one particular period of time, like the Jurassic. Okay? So if you're studying Jurassic theropods from North America, wow! Now you've got a narrow topic you can actually get your mind around. Actually, you should narrow it more than that. You should, because that's still actually a little bit too broad. Rather than theropods, you should look at Tyrannosaurus rex or another particular species. Okay, you all follow what I'm saying here about how to narrow your topics. This is what we do all the time. We start with a big idea and end up carving chunks of it off and saying we can't do everything, we can't do everything, we can't do everything, and end up with something we can actually do. Okay? I'll use Jeremy as an example. He's really interested in wetlands. That's a very big, complex topic. So, what does he do? He narrows it by the phenomena under study. Only wetlands that have seen a particular kind of change. Okay, by geographical area, in Alabama, by time period, current. So current wetlands that have seen a great deal of change in Alabama. That's a project he can actually do as a graduate student. And actually, you ended up narrowing it down to one particular wetland, right? And so he's likely to succeed in part because he properly narrowed his graduate thesis down that narrow.
Okay, so when we do our projects, are we trying to solve a problem? Or,
Yes.
okay, and then while we're trying to solve this problem, let's go back to the droughts for a second. If we're talking about temperature droughts, we can't use any of those other variables that might have happened because of the precipitation droughts. So it's just like, if we're looking at one thing, it's just like, I guess I'm getting confused a little bit on how, like, we can solve this problem if there's such a wide spectrum.
Well, and that's why you got to keep narrowing until you can actually deal with it. And at first, because you want to study everything,